Welcome to this class. In this session, we are going to introduce the concept of implicit differentiation. So we'll define or differentiate between functions which are implicitly defined and functions which are not implicitly defined, and then state the steps to follow to carry out implicit differentiation. And the next session, we'll do examples. So, say the equation or equation of the form y equals to f of x expresses y explicitly in terms of the variable x. So if you have y equals to f of x, then y is explicitly expressed in terms of the variable x. But consider the following functions or equations. Let me just say equations, not necessarily functions. So, first one, x cubed plus y cubed plus 9xy equals to 0. We call this one A. And then B, y squared minus x equals to 0. C, x squared plus y squared minus 25 equals to 0. D, xy minus 1 equals to 0. Say E, x squared plus xy sine y equals to 0. F, x squared plus e raised to power xy squared plus 3y equals to 0, etc. So consider these 6 equations. What is common for all these 6 equations is that these 6 equations define an implicit relation between the variables x and y. So in all these six equations, we define an implicit relation between the variables x and y. In some cases, we may be able to solve such an equation. So we are meaning that an equation which is in whose variables x and y are defined implicitly. For y as an explicit function of x. So in some cases, we may be able, like this case B, we have x squared, y squared minus x squared, x equals to 0. So from this one, we can say y squared is equals to x. So y is square root of x. So this is y is expressed in terms of x. Or in C, so we have x squared plus y squared minus 25 equals to 0. We can write this one as y squared equals to 25 minus x squared. So y squared, y square root 25 minus x squared. So you express y to be plus or minus square root of 25 minus x squared. So for this a given specific example, and this one here, we can express y explicitly in terms of x. But equation like 1, x cubed plus y cubed minus 9xy equals to 0, we may not be able to express y explicitly in terms of x. So a case whereby that is possible, it's not possible to express y explicitly in terms of x, then that's when we carry out what we call the implicit differentiation. So when we cannot express an equation of the form capital F of x comma y equals to 0 in the form y equals to f of x, then we say that the function f of xy is implicitly defined in the variables x and y, and the process of finding dy dx in such cases is called implicit differentiation. That's what we call implicit differentiation. So now what we're going to do, going to give the steps on how to carry out implicit differentiation, and then in the next session we'll give examples on how to carry out implicit differentiation. So steps for carrying out implicit differentiation. So there are 4 main steps. So step 1, differentiate both sides. Both sides of the equation with respect to x, i.e. supply d dx on each term of the equation So you want to assume that the implicit relationship is a function of 2 variables, x and y. But anyway, even if there are 3 variables, still will work. So that's step 1. Number 2, collect all terms involving dy dx on the left-hand side of the equation and move all other terms to the right-hand side of the equation. So the thing that differentiate both sides of the equation with respect to x, keeping in mind that y is a differentiable function of x. So whenever you have a y in any of the term, then you attach to that derivative dy dx, because y is assumed to be the differentiable function of x. Number 3, factor dy dx out of the left-hand side of the equation. And lastly, make the subject of solve for dy dx by dividing both sides of the equation by the left-hand side factor that does not contain dy dx. So those are the steps to follow when we are carrying out implicit differentiation. Now, just as an example, when we're defining the implicit and explicit forms, so if we have an equation of the form xy equals to 1 or xy minus 1 equals to 0, then we call this one an implicit form. And when we say 1 equals to 1 over x, then this is what we call explicit form. So explicit form means that one variable is on one side and the other side is taken by the other variable. But for implicit, all the variables, one side has terms which have all types of the variables under consideration. So in the next session, we'll do examples to illustrate how to carry out implicit differentiation. Thank you.